Okay, let's go back to Einstein. What is general relativity and what is special relativity?
Well, in 1905, he came up with his theory of special relativity, which is explaining the dynamics of the universe where you only look at the velocities of the different objects in the universe.
Light.
Light in particular.
Which is constant in terms of speed.
Velocity of light is constant. But it was in 1916, he said, I'm not only going to look at the velocities, I'm going to look at the accelerations. And special relativity is not that intellectually challenging, but general relativity is extraordinarily intellectually challenging. It took the genius of Einstein to come up with general relativity. And it explained not only the velocities, but the accelerations of all the bodies in the universe. And what was remarkable, Einstein, in developing his theory, said, here are three specific ways you can put my theory to the test. These are the observations that, if successful, prove my theory, if not, disprove my theory. And within a few years after he published it, astronomers were able to put his theory to the test, and it passed with flying colors.
Yeah, but it also led him to a conclusion that he didn't like. What was it?
Well, the conclusion he didn't like was that if his theory of general relativity is true, the universe has a beginning. It's not infinitely old. And that's why he threw in this extra term in his equations. But when he looked through the telescope on Mount Wilson with Edwin Hubble, he recognized, you know what, the way I produced my general relativity originally, that's the correct formulation.
He fiddled with his own math to make it come out the way he wanted. He had it correct the first time,
right,
but then he fiddled with it so that it would come out to be an infinite universe. And it was Hubble that said, I want you to come on over here and look through my telescope, and I want to show you that the galaxies are moving away.
Yes.
And what happened?
Well, he looked at his paper, he looked through the telescope and said, you know, that fudge factor I put into my equations, it's the greatest blunder in my scientific career. And that was picked up by newspapers around the world. But here's the irony, John. Today, we're reviving his cosmological constant. He had the wrong value and the wrong sign, but today we're actually appealing to his cosmological constant to explain a feature that astronomers have seen that Hubble did not see. It's not just that the universe is expanding, the expansion rate is accelerating. So we revived his cosmological constant, but different sign, different value.